So hello guys, welcome to the second session of chemistry class, and today we are going to study structure of atom. So before going further, remember these three names. So first one is J.J. Thomson, second one is Goldstein, and third one is Chadwick. So J.J. Thomson discovered electron, Goldstein discovered proton, and J.J. Chadwick discovered neutron. Okay, and we are going to study the structure of atom and various models proposed by some of the famous personalities, that is Bohrs model of atom, Rutherfords model of atom, and some other concepts. Okay, so we will see. So first one is Thompson's model of atom. So according to Thomson, electrons are embedded in a positive sphere, and you can consider the example of watermelon. It best suits his model. Suppose you consider watermelon, the reddish part in it is known as protons and all the seeds are considered as electron. So his model was based on that concept. So according to Thompson's model, there are two concepts. The positive charge sphere is embedded with electrons, and second one is negative and positive charges are equal in magnitude, and that's why the atom is neutral, that is, it is balanced. Okay, that's the Thomson model, but it could not explain all the concepts which are further said by scientists. So we will see the next model, that is Rutherfords model. Okay, so Rutherfords model is based on alpha ray scattering. Okay, and how he was doing the experiment was because he was interested in knowing how electrons are arranged in an atom. So he experimented the concept of alpha ray scattering, and he got these following results. Okay, and alpha particles are nothing but helium ions. So after he performed the experiment, he got these three results. So the results are, most of the particles passed through the gold foil, directly passed, and some were deflected with small angles, and 1 out of 12,000 rebounded with the angle of 180 degree. And this was an interesting result, that 1 out of every 12,000 rebound with an angle of 180 degree. So these are the three concepts. So on this basis, he said that most of the space in an atom, that means the positive charge is located in a small space, and that's why some were deflected with small angles. Okay, if the space with positive charge was more, then they would deflect, more particles would deflect, right? So only small amount of particles deflected with small angles, and only one out of many were deflected with the angle of 180 degree. So therefore he concluded that the positive particles are located in a small region, that's why there is a small space, that means where the nucleus is located. So he concluded that this part. Okay, so according to Rutherford's nuclear model, there are three concepts. He said that positive charge center is known as nucleus, and it has it has protons. Okay, and electrons revolve around the nucleus in well defined orbits. And the third is, size of nucleus is very small compared to the size of atom, and the entire mass of atom is located in this nucleus. Okay, Rutherford's model was satisfactory to a certain limit, but it has a drawback. So he said that electron revolving around the nucleus in certain orbits, right? So when electron starts revolving in certain orbits, it would radiate energy, and finally it may fall in the nucleus, right? And that's why according to him it was unstable. Atom was unstable. So here he went wrong, and because of this it was a major drawback. But in today's case we can see that the atom is stable, that's why the most of the matter is formed, right? If the atom were unstable, the matter would not be existed in the form as we see now. The drawback was electron would revolve due to acceleration, it would radiate energy, and with the loss of energy, electron would fall inside the nucleus, making the atom unstable. But atoms are stable. That's why the matter is, we can see the matter in various forms. So Bohr's model of atom. So according to Bohr, only special orbits or the energy levels are allowed inside the atom, and electrons, this was the main definition that Rutherford could not tell. He said that electrons emit energy while revolving, but Bohr said that electrons do not radiate energy, and that's why the atom is stable, and maybe he is right. So these orbits and shells are known as energy levels, and energy levels are indicated using the letters K, L, M and so on, where N stands for 1, 2, 3, and in these orbits, specified orbits, electrons revolve around the nucleus. So that was the Bohr's model of atom. So the next concept is rules for writing number of electrons present in an atom, and this concept was given by Bohr and Bury. So according to them, the maximum number of electrons in an atom is given by 2n square, where n is the orbit or the shell. Suppose it is k orbit, so the number of electrons that can be accommodated in k are 2 into 1 square, so it's the first orbit, right? So 2, and similarly for L, the orbit number is 2, so 2 into 2 square, that is 4, 4 2 is 8, so the number of electrons can be accommodated is 8. So the second rule was maximum electrons in outermost orbit present can be only 8, and electrons are arranged in the shells according to stepwise manner, that is, first the innermost shell is filled, then the next one, then the next one, and similar wise. Okay, one more concept is concept of valence electrons. So what are valence electrons? Valence electrons are nothing but the electrons present in the outermost shell of the atom. Okay, so the valency of atoms can be different, so based on the number of electrons present in the outermost shell, that is known as valence electrons, and the concept is known as valency. The next concept is atomic number and atomic mass number. So what is atomic number? Atomic number is nothing but number of protons. For example, hydrogen has 1 proton and carbon has 6 proton. So atomic number of hydrogen is 1 and carbon is 6. So atomic number is denoted by letter Z, and it's nothing but number of protons. So what is mass number? Mass number is nothing but number of protons plus number of neutrons, and protons and neutrons are together called nucleons. So for example, mass of carbon is 12U because it has 6 protons and 6 neutrons. Okay, remember these two concepts to solve some problems. Now next we will see about isotopes and isobars. So what are isotopes? Isotopes are nothing but atoms of same element with same atomic number but different mass number are known as isotopes. For example, hydrogen is an isotope, and examples of hydrogen are protium and deuterium. Okay, these are isotopes. Now what are isobars? Atoms of different element having same mass number but different atomic number are known as isobars. For example, calcium has atomic number 20 and argon has atomic number 18, but the mass, that is number of protons and neutrons, is 40. So these are isobars and these are isotopes. So these are isotopes and isobars. They have specific applications in specific fields. Just go through them. Okay, that's all about structure of atom, and if you like the video, do like, share, and please subscribe.